Alright, so let's finally implement a class that uses the visitor pattern to serialize the different types of nodes of our abstract syntax tree. What I'll do is I'll create a new package called analysis in the AST package. So this will contain all the logic of the visitor. Right, what I'll do is I will create an expression visitor. Expression visitor. It visits all the expression nodes. This visitor is going to be a generic type. Why is that? Because the AST printer will return the class that we are required to implement. The AST printer needs to return a string. But in the future, when we evaluate expressions, uh, in that case, the visitor will not return a string. It will return something else. So I need the interface to be generic, which is why this returns an R, and I create a method called visit binary, and in it I write a binary and then expr. All right, that is the visitor for binary. Let's create one for unary, and import it. Let's visit a grouping expression. And let's finally visit a literal expression. Let's call it literal. All right. Okay. And let's now create a class that implements it. New class. Let's call it AST printer, or you can maybe call it a serializer visitor or something like that. Let's just call it AST printer to be inconsistent with the book. To be consistent with the book, sorry. And it implements the expression visitor with the type string. So let's just hit it, and this gives me 4 methods. All right. And see, let's decide. It's easiest to decide how a literal is serialized. So if a literal expr literal dot value, it's null. In that case, we return nil. That is the how it should be printed. And otherwise, what we'll do is expr dot value dot toString. That's it. That's it. That's all we need to do. And let me once read what they require of us. So you see, booleans and nils. So that the literal will take care of booleans and nils. It will also take care of number literals. It will also take care of string literals. Now comes parentheses. This is the grouping. All right. So a grouping is printed like this. A group, first brackets, then a group, then the thing that was inside the expression. All right. So what we need to do, let's create a method that adds these parentheses to the output. All right. So let's create a private parenthesize, and it parenthesizes string name and the expression expressions. So I can private, and it returns a string. All right. And what we need to do here is, all we need to do is we need to create a string uh, string builder, new string builder. All right, and to the string builder I will add the brackets I was telling you about. Then we append the string we sent it down. Sorry, it should be name. All right, and after that, for each expression, for expression e in expressions, we add a space before it. So sb dot append space, and then we do an sb dot append of whatever the expression was, e. We do not have the accept method right here. So before going forward, I need to add the accept method right here. Like in my previous video, I showed you the abstract class, the common class needs to have the accept method. So it's going to be a public abstract. It is also generic. Let's name it differently. It returns a T and it's called an accept, and it takes an expression visitor of type T visitor. All right, so now all my expressions will have a new method in it. Similarly, in my grouping, there will be a new method. In my literal, there needs to be a new method. And in my unary, I need to create a new method. And like I showed you in the previous video, the logic inside it is going to remain the same. We're not going to, the logic inside this in all the different classes will be the same. All we'll do is visitor dot visit. We are in binary, so we'll visit the binary with this. Similarly, in grouping, we will visit dot visit grouping with this. In literal, we will visit dot visit literal with this, and finally in unary I will visit dot visit unary with this, right? And now in my AST printer right here, what I can do is I can e dot accept expression dot accept, and I can pass in the current visitor, which is the AST printer. That's what I need to append right here, and after that I can do sb dot append the closing bracket. All right, and I can return sb dot to string. So why am I doing this? So the grouping expression, is this, an object of this class will be created when in a list of tokens I see a bracket, then an enclosed expression, then a closing bracket. But nowhere here am I keeping the brackets, right? I'm only keeping the enclosed expression. So whenever I'm serializing the grouping, I need to add those brackets by myself. And it only has the grouping object, only has the enclosed expression. Now this expression, it's in itself may be binary. All right. So where is the AST printer? The grouping, this creates something like this, the enclosed expression, this. But if the enclosed expression is a binary, then it needs to be, it creates a group, and like this. This is what this visiting grouping needs to create. But in case this enclosed expression is a binary, then this enclosed expression needs to be serialized as well, recursively. That's what this will do. 1 and 2. That's what this will do. That's what this e.accept of this will do. It will call the visit method on the enclosed binary expression and return this. And that's what we are appending to the string. All right. So right here, all I need to do is called parenthesize, and I will parenthesize it with for the first thing here is going to be a group, and then the following enclosed expression, which is the expr dot expression. Right. That's how we parenthesize a grouping. That's how we serialize a grouping. Now for the unary, let's see how the unary looks like. That is the parentheses. For unary, you see, we have an operator, then we have a boolean. How do I get this operator? Let's see, in my unary, I have a token, and in the which is the operator, and in the token, I have something that is lexeme. This lexeme will be equivalent to the operator character, and this should be public. This should be public. All right, that this parentheses we can get from lexeme. So we have that in the unary. And this true, where will this true come from? Let's see. In my unary, I have an expression. I have an expression on the right. This expression, when we serialize it recursively, will give us the boolean. All right. So in my AST printer, I need to call parenthesize with you expression dot operator dot lexeme, comma, and the expression on the right, expression dot right. What this will do is it will recursively serialize this and parenthesize it with this by adding a space in the middle. All right, let's see how a binary operator is serialized. So let's just take this. Let's just take this for an example. 16 into 38. So you see, we get the operator. Again, this will be achieved. We will get this from the operator lexeme. And then we have two expressions, two numbers. And how will we get these? These are literal expressions which are on the left and then the literal expression on the right. So visit binary is simply going to be parenthesize, and this is going to be the expression dot operator dot lexeme, and then expression dot left, and then expression dot right. All right. I think that is it. We also need one generic method to visit all the expressions. All right. So in our AST, we will create a utility method, public string, and it takes a print and it takes a generic expression, and it returns expression dot accept, and we pass it this. So now we can give it any expression. We can call this print method with any expression, and it will recursively what you call it, serialize it. Later on, we will add ternary expressions. CodeCrafters don't tell you to do that, but I did. I added that to the logs language because the writer of the book they tell you to read, the writer of this book has added that as a challenge. You see there, he has challenged you to write the comma operator. He has also challenged you to write C-style ternary operators. So I added both of these to my language. So we will add those to the expression visitor and the AST printer as well in the next or the next to next video. Probably the next to next video. In the next video, we will be wiring up a parser, and we will parse the tokens into abstract syntax tree, and we will be using this AST printer to serialize it and print the output to the screen like how they want us to. They want us to print, they want us to create an abstract syntax tree, and then they want us to serialize it, right? That's basically what they tell us to do. So we will be doing that in the next video. We at least have the a fully functioning AST printer. No, not fully functioning. It doesn't have a ternary operator or a comma operator. We will add that soon, but stick around for that to the next video, and I'll see you in the next one.